Welcome everyone. Myself Moushumi Shaha, Assistant Professor of Computer Science and Engineering Department from Narula Institute of Technology. Today our topic is thread. So first we discuss what is thread. A thread is a path of execution within a process. Like a process can contain multiple threads. A thread is a basic unit of CPU utilization consisting of a program counter, a stack and a set of register and a thread ID. A thread is also known as lightweight process and each thread belongs to exactly one process and no thread can exist outside of a process. So basically a process is divided into number of lightweight processes. Each lightweight process is said to be a thread. The thread has a program counter that keeps the track of which instruction to be executed next. So, if a process has register which hold its current working variable, the thread has a stack which contain the executing thread history. So, number of thread can share an address space. Open file and other resources. Okay. Same as the number of processes can share physical memory, disk, printer and other resources. Because of a thread have some properties of a process. The thread operations in many respects in the same manner as process. The thread can be one several state, like the thread have also ready, block, running and terminated state like process. A thread share the CPU and only one thread at a time is active, or that means in running state. The thread can create child thread. Unlike process, the thread are not independent of one another. Create a child thread. Unlike process, thread are not independent of one another. Because of all thread can access every address in this task. A thread can read or write memory. So here a single thread process. Here in this process there is only one thread. They share the code, data, file, stack, register, and this process have multiple threads. Okay, so the human body perform a great variety of operations in concurrently. For example, seeing, touching, smelling, teasing and hearing can occur concurrently. An automobile can accelerate, turning, air conditioning and playing music connectively. So the program specific the application contains thread of execution. Each thread design a designated portion of program that may be executed concurrently with other thread. The capability is called multi-threading. Okay, so the life cycle of a thread is there have bond state when a thread is just created. A thread have ready state when a thread is waiting for processor. It is in running state when the system assigns the processor to the thread. A thread can be in block state when a thread is waiting for an event to occur, then or an input-output device to occur. That time it moved to block state. A sleeping thread became ready after designated sleep time expire. The execution of thread is finished, that time it go to dead state. Okay, so the example of thread is a programmer wishes to type a text in a word processor. Then the programmer open a file in a word processor. Okay, we all use the word processor. So suppose I want to or you want to write something. So for that the programmer open a file or a word processor and typing the text. So the typing is one thread. The text is automatically formatting, that is another thread. The text is automatically specify the spelling mistake, that means it automatically spell check, that is another thread. And the file automatically save, that means after a several time it was we saw now the saved in draft. Okay, so it automatically saved, that is another thread. So typing a file is a process, but typing, formatting, spell checking, saving, these are the thread. Okay, so now what is the difference between process and thread? A process can't share the same memory area, but a thread can share the same memory files. Process may any program in execution, but thread means segment of a process. A process takes more than time to terminate. Okay, it takes more time to, but a thread takes less time to terminate. The process takes more time for creation also, but the thread takes less time for creation. The execution is very low in process and the execution is very fast. So, and for process it takes more time to switch between two processes, but in thread it takes less time for context switching. The process is less efficient in terms of communication, but the thread is more efficient in terms of communication. The process consumes more resources, but compared to that, the thread consumes less resources. So processes are loosely coupled, and we can say the thread are tightly coupled. System calls are required to communicate with each and every process. For communicating, the process requires system call. System calls are not required to communicate between thread. Processes are not suitable for parallel activities, but threads are suitable for parallel activities also. Okay. So these are some difference between process and thread, and the advantage of thread is the thread minimize the context switching time. Use of thread provide concurrency within a process, and communication is efficient. It is more economical to create and context switch thread. The thread allow utilization of multiprocessor architecture to a great scale and efficiency. And the disadvantage of thread is blocking of parent thread will be block all the child thread. Okay, and there are some securities or issues also. Mainly there are two types of threads are there. Okay, so one is user level thread, ULT. Second one is kernel level thread, KLT. What is user level thread? This type of thread loaded entirely in the user space. The kernel knows nothing about them. When the threads are managed in user space, each process needs its own private thread table. This thread table consists of information for program counter, stack pointer, register, state, etc. This thread table managed by runtime system. When a thread is moved to ready state or block state, the information needed to restart it is stored in the thread table. Okay, so the advantage of user level thread is the user level thread allow each process to have its own scheduling algo. The entire process loaded. Okay. The entire process loaded in the user space, so the process does not switch to the kernel mode to do the thread management. This saves the overhead of two mode of switches. The user level thread can run on any operating operating system. And the disadvantage of user level thread is when a user level thread executes a system call, not only the particular thread blocked, all the threads within this process are blocked. In the user level thread, only one single thread within a process can execute at a time. So multiprocessing is not implemented. But in kernel level thread, the kernel level thread does the kernel does total work of thread movement. There is no thread table in each process. The kernel has a thread table that keeps track of all the thread in the system. When the thread wants to create a new thread or destroy any existing thread, it makes a kernel call, which takes the action. Then the kernel's thread table holds each thread register, state, and other information. The information is the same as the user level thread, but it is now in the kernel instead of user space. Okay. So the advantage of kernel level thread is the kernel can simultaneously schedule a multiple thread from same process on multiple processor. It means it supports multiprocessing, whereas the user level thread can't support this. A thread in a process is blocked. Then the kernel can schedule another thread for the same process. The kernel routine themselves can be multi-threaded, or scheduling by kernel is done by on a thread bus. And the disadvantage of kernel level threads are more cost for creating and destroying the thread in the kernel. The transfer of control from one thread to another in the same process require a mode of switch to the kernel. Okay, so the user level thread are implemented by user, where the kernel level threads are implemented by the operating system. The operating system does not require the user level thread. Kernel thread are recognized by operating system. Implementation of user level thread is easy. Implementation of kernel level thread is complicated. So context switching is less in user level thread, and context switch time is more in kernel level thread. Context switch require no hardware support. In user level thread, the context switch require no hardware support, but in kernel level thread, the hardware support is needed. In user level thread, if one user level thread perform blocking the operation, the entire process will block. But in kernel level thread, if one kernel thread perform blocking the operation, then another thread can continue execution. The example of user level thread is Java thread, POSIX thread, and the example of kernel level thread is Windows, Solaris, etc. So in some of the operating system provide a combined user thread and kernel level thread facility. The Solaris is a good example of the combined approach. In the combined system, multiple threads within the system, same application can run in parallel or multiple processor, and blocking system call need not to block the entire process. The multi-threading model are three types. One is many-to-many, many-to-one, or one-to-one. So what is many-to-one model? In this model, we have multiple user thread mapped to one kernel thread. Okay, there are multiple user thread that map into one kernel thread. In this model, when a user thread makes blocking, system call entire process block. As we have only one kernel thread and only one user thread can access kernel thread. Okay. So the multiple thread are not able to access multiprocessor system. So the next one is one-to-one model. Okay. Here in this model, one-to-one relationship between kernel and user level thread. In this model, multiple thread can run on multiple processors. Problem with this model that is that creating a user thread require the corresponding kernel thread. And the next one is many-to-many model. In this model, we have multiple user thread multiplex to some or lesser number of kernel level threads. Now, number of kernel level threads are specified to the machine. Advantage of this model is if a user thread is blocked, we can schedule other user thread to other kernel thread. Thus, the system does not block if a particular system. So, thank you for today. Okay. So, the benefits of thread is a thread can less the time to terminate than a process. It takes less time to switch between two threads within the same process. It takes less time to create a new thread within the process, and efficient communication between threads. So that is all for today. If you have any query, okay, these are some reference book. You can follow the book for reading. And if you have some queries related to this topic, you can contact me. Thank you.